Hey guys, happy Pi Day. Today is March 14th, which is officially Pi Day. And I think one of the best ways to celebrate is to imagine a world without pi so we can realize how lucky we are to have pi in our lives. So I'm going to show a potentially realistic scenario where we would have never made pi. First, let's go back in time a couple thousand years before pi was ever created. In this scenario, ancient civilizations were fascinated with unit cubes. That's cubes with a side length of 1. And one thing they love to do is put the cubes next to each other and measure the various diagonals. When you look at these different lengths, the sides and the diagonals, you end up with square root of 1, square root of 2, square root of 3, square root of 4, square root of 5, and square root of 6. This ancient civilization was fascinated with the length of the diagonal of the two adjacent unit cubes. They loved it so much they gave it a constant alpha. And that alpha was equal to square root of 6, or approximately 2.4494897.4. This alpha was very important to this civilization. Let's put a box around it. And let's make another box, go forward 100 years, and move a couple hundred miles away. Our new society is aware of this society's alpha, and they also really liked sums. There's one sum that they love so much. It's the sum of the reciprocals of the perfect squares. 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared, going on forever. This society was fascinated with the sum, and they gave it a constant beta. The reason they didn't give it alpha is because they knew about this culture already assigning alpha to this. So they gave it beta. After you figure out this infinite sum, beta is approximately equal to 1.6449, 340,668, and so on. And now let's go forward a couple hundred years and move another couple hundred miles away. We're on to a new society that knows about this society's alpha and this society's beta, and they have a fascination with circles. They love to study the relationship between the circumference and the diameter. And after taking a bunch of measurements, they found out it was approximately 3.14159.265 and so on. But there was something else they discovered. When you take alpha, the square root of 6, and multiply it by the square root of beta, which is the square root of this sum, you get exactly 3.14159, the circumference over the diameter. Isn't that interesting? When the mathematician first discovered it, he couldn't believe it, that the ratio of the circumference over the diameter was equal to this ancient constant times the square root of this ancient constant. He was in such disbelief he had to double check it on Wolfram Alpha. And here it is right here on Wolfram Alpha. If you take the square root of 6 and multiply it by the square root of the infinite sum of the reciprocals of the perfect squares, it's equal to the 3.14159 number. When he discovered this, he shared it with the scientific community, and they were so excited. It was official. The ratio of the circumference over the diameter was equal to alpha times the square root of beta. There was no need to simplify this further. And then a whole bunch of math followed from there. The circumference of a circle was found to be the diameter times alpha times the square root of beta. Or you could also say 2 times the radius times alpha times the square root of beta. And the area of a circle was r squared alpha root beta. Eventually, a guy named Euler discovered this beautiful identity. It was e to the I alpha root beta plus 1 equals 0. This became a hugely famous identity because he used all the elegant numbers e, I, alpha, beta, 1, and 0. And then eventually high school students are going to study trigonometry, and they're going to find things like the sine of 2 alpha root beta over 3 is equal to root 3 over 2. A whole bunch of society ends up being built off of this alpha root beta. Even college students studying probability would have the normal distribution function defined as 1 over sigma square root of 2 alpha root beta times e to the negative 1/2 x minus mu over sigma squared. This is what all our math could look like if we never had pi. But luckily, our society is different than this society. We assign the circumference over diameter equal to pi, and now thanks to pi, all of this math is much more elegant. Thank you, pi. I love you. Happy Pi Day. How exciting.